Today I am presenting here IC activity of the refrigeration and air conditioning. So my topic is laboratories and research facilities. So first of all, introduction of the or my report. Refrigeration is the backbone of the our laboratories and research facilities industry, and also we can use in the car refrigeration, in our home fridge, and many more air conditioning, and then other laboratories. So refrigeration is a need of the human being. So refrigeration is backbone of the modern laboratories. It ensures the biological chemical samples remain safe of the years, and in biobank refrigeration, pressure DNA, then RNA, plasma, tissues, salivas, and other examples we can take in the laboratories for in using a refrigeration system. So overview of the industry, biobank. We taken the biobank from the laboratories. So this is the biobank, our main industry in our case study and report. Then a biobank collect the process and result biological samples for the research, domestic and drug development. And for example, UK Biobank, CSIR labs in India, then COVID-19 bio bioresources in our India. So we use the in laboratories and research facilities. There are used the cascade refrigeration system. So now we can see the workflow of the refrigeration system. So here the cascade refrigeration system are used. The typical workflow: the collection, assessing the labeling, then process, centrifugal alkylam, then snap freezing, storage. There are 2 to 8 degrees Celsius to -20 degrees Celsius, also -80 degrees Celsius temperature used in the refrigeration system. Then this is the cascade refrigeration system circuit diagram. So here are the 1 to 2 process are the low temperature vapor compression are delivered to the cascade condenser. So in the 2 to 3 cascade condenser process are done. Then 3 to 4 the expansion valve. Here the low temperature, low vapor compression, vapor generated in the then through the evaporator. Then again they high high temperature high temperature high temperature vapor are gone through the compressor. There are the process are shown. The compressor, the LT compression, bottom right, compress the low temperature refrigeration from the low pressure vapor to the high pressure vapor. Then cascade condenser work as instead of the rejecting the heat ambient, then this vapor is condensed in the cascade condenser, which act as a condenser for the LT cycle, means low temperature cycle, and evaporator for the high temperature cycles. Then expansion valve, the high pressure liquid refrigerant expand the low temperature expansion valve. Then point 4, at point 4 dropping its pressure and temperature. So this is the low temperature for the this upper side. Then this is the shown in high temperature. Then role of the refrigeration system in laboratories and research facilities: preserve the molecular integrity of the DNA, RNA, and proteins and protect the cell membranes by preventing ice crystal formation, then provide long-term storage for the large sample event, ensure the compliance with the regulatory standards. Refrigeration system used. Cascade vapor compression system are used for the laboratories and research facilities for the -80 degrees Celsius storage of the DNA and RNA plasma. Then striling ULT freezers, energy efficient free piston striling coolers. Then LN2 cryogenic system. This is also refrigeration system. This is for the -150 degrees Celsius to -190 degrees Celsius for the cell and tissue storage. They preserve and protect the tissues and cells. And Key components of the refrigeration system: the compression, high temperature and low temperature, and cascade condenser act as a condenser for the low temperature also, and evaporator for the high temperature. Then expansion wall, evaporator, inserted cabinets, and sensors, controllers, UPS backup, and cryogenic tanks are used in our two refrigeration system, cascade also, and this L2 LN2 cryogenic system. Then temperature requirement: 2 to 8 degrees Celsius for the uh, short term lignite and diagnostic kit, and -20 degrees Celsius enzymes and chemicals, and -80 degree for the long term DNA and RNA and plasma storage, and -150 to -190 degrees Celsius for the stem cell tissues in the LN2 storage. The challenges faced our refrigeration system: first is high electricity consumption, then second risk of power failure and leading to the sample losses, in refrigerant regulation and environmental concern, then maintenance and frost formation issues. This is because the high temperature required means low temperature required for the tissues and cells to protect in -80 degrees Celsius, and in LN2 for the -150 degrees Celsius to -196 degrees Celsius. Then recent innovation, we developed the refrigeration system, natural refrigeration system, R290, and also R170 in cascade system. The pre-piston stirring freezers for the 70% energy savings. Then IoT enabled monitoring we develop, and also predictive maintenance, and automated robotic samples achieves at -80 degrees Celsius. So we taken the here case study, simple case study in the UK Biobank for the laboratories and research facilities. So one of the largest biobank globally with greater than 5 lakh participants, and then uses automated -80 degrees Celsius samples archives with robotics retrieval system, and ensures uniform cooling, reduces door opening and maintenance data integrity. For example, advanced refrigeration system supported global health research. This case study are done in the UK Biobank. So I take the references of the Arrow CP refrigeration and air conditioning, Aurora, and Pittenley H Biobank for the method and protocols. Then energy report journal. We also use the books and also use the Google research papers, and also one of the Aurora CP refrigeration and air conditioning.